Hey, it's Mr. Kingsbury from your Algebra 2 class. Today we are going to be talking about another type of factoring from our factoring unit. This type is called the difference of two squares, or dots. You'll hear me say dots a lot in class. That's what it's referring to. Don't forget to put your period and the date in your notes. And our essential question today is, how do I factor an expression that is the difference of two squares? Now, before we get into the how, you need to understand where it comes from. If you think back to Algebra 1, hopefully there was some discussion about multiplying binomials. And usually when people multiplied binomials, they were fairly different. They could be pluses, both minuses. They could be, they could have coefficients in front of the x. There could be variables in all the terms. There was a lot of variety. And because of that, there weren't a lot of patterns that emerged. Certainly there were general ways of factoring that came out of that. That's kind of reverse engineering this. But there wasn't a lot of patterns popping up. And mathematicians like patterns. They like to find kind of special cases that make life a little bit easy. So, they would do something like this. They would multiply something like this, and they would end up getting four terms that they could put together. And it wasn't terribly exciting, but, it is what it is. So they worked with that. And then someone came along and said, hey, I got a question. What if, by the way, this ends up being x squared plus 3x minus 7x minus 21, and then you can put those two terms away together, but we're not real worried about that. So someone came along and said, all right, so we've been multiplying all these binomials and stuff, and that's all well and good, but what if instead of having all this great variation, what if instead of having everything be different, what if we took and we multiplied something by itself? And they discovered when they did this that a pattern did in fact emerge. And it didn't matter if the binomials were both adding or both subtracting. There was a pattern that popped up. And from this, we get what is called a perfect square trinomial. This was a special case. And what happens then is if you recognize that your trinomial is a perfect square trinomial, then you can factor it very quickly because you know it follows the pattern. But after that, then someone said, wait a minute, we've done them both the same, with the numbers the same. What if we did one where the numbers were the same, but the signs were different? So one plus and one minus. And something interesting happened. They got the following four terms: x squared minus 4x plus 4x minus 16. And these terms right here are like terms. So we can combine them, and what we end up getting is x squared minus 16. And so they tried a bunch of these, and I could do a bunch of them for you if you wanted, but suffice it to say, mathematicians tried a number of these, and they discovered a pattern popped up. That every time they multiplied two binomials, where the terms were the same, but the sign was different in the middle here, one adding and one subtracting, they found that the result was always a perfect square minus a perfect square. And of course, when we subtract things, we say we're finding the difference. So they started to call this the difference of two squares. And the pattern emerged that if you took the square root of each of these terms, all you had to do is add them and subtract them, and those were your factors. So using this pattern that came about, it was discovered that in a very specific situation, a situation where you have a perfect square minus another perfect square, you can factor it very quickly by just taking the square root of each side, adding them, and subtracting them. So that's what we're going to do today. That's where it came from, where the name comes from, and that's what we're going to look at. It's actually pretty easy to do. Once you've done it a couple times, it becomes really child's play. So let's start simple. Let's say I have x squared minus 25. If I want to factor this, I know that one of my factors is going to be plus, and one of my factors is going to be minus. I know that the first part of each of my two factors will be the square root of x squared, and the second part will be the square root of 25. So I need to know what is the square root of x squared? That's x. And what's the square root of 25? That's 5. So I'm going to have x plus 5 and x minus 5. That's it. That's all there is to it. Let me show you another one. Let's say we have, I don't know, how about x squared minus 36? So I know one of my factors will be plus, one of them will be minus. I just need to take the square root of each of these. So the square root of x squared is x. The square root of 36 is 6. So I have x plus 6 and x minus 6. Not that complicated, promise. And after you do 2 or 3 of these, they will be so easy you'll be doing them in your sleep. Let's try another one. I'm going to raise the difficulty just a little bit, but there's really not a whole lot I can do to make it more difficult except give the x squared a coefficient. So let's say that we have 16x squared minus 49, and I'm going to factor that. Once again, I know one of my factors will be plus, and one of them will be minus, no big deal. So I just need to know what is the square root of 16x squared. Well, the square root of 16 is 4, and the square root of x squared is x. What's the square root of 49? That would be 7. So I have 4x plus 7 and 4x minus 7. That's about as tough as it gets. I'll do one more just so you have one more to reference, but it doesn't get any more difficult. I mean, I guess I could make the numbers really big, like 169x squared minus, I don't know, 225. You have calculators. You can find some square roots. No big deal. Let's factor it. I know one will be plus and one will be minus. The square root of 169x squared is, well, the square root of 169 is 13, and the square root of x squared is x. The square root of 225 is 15. So I'm going to have 13x plus 15 and 13x minus 15. And that's it. That's all there is to it. We're going to practice this a bit in class, and hopefully you guys will latch onto it really, really quick. Thanks for playing, and I'll see you later.